mass ejections. The reason I want to talk about this is because of the solar eclipse that is going to be happening on August 21st, which I'm super excited about. So a coronal mass ejection is an explosion of magnetic fields and plasma from the sun's corona. And the reason I bring this up is because during a total solar eclipse, the moon is crossing between Earth, like say you're Earth and I'm the sun. This is the moon crossing between, and it reaches a point where it covers the majority of the sun, and all that's kind of left is this little bit of a halo around the sun that is part of the corona. So the sun is a big ball of plasma. It's really hot. It has a lot of stuff going on inside of it, like nuclear fusion, which is elements being converted into one another, like hydrogen being pressed under a really high level of pressure and temperature, and that then transforming into helium, that transforming into deuterium, and so on and so forth until about iron. With plasma, so now with what's happening is the sun has its own electromagnetic field. Electromagnetic field is brought on by its gravitational pull and its rapid spinning, which is also brought on by its really strong gravitational pull. When this is happening, it's getting excited electrons that have an electrical charge, and photons have an electrical charge, and that then transforms into a electromagnetic field. Earth also has an electromagnetic field. So when the sun has like an explosion, where it usually will come from like sunspots. Sunspots are area on the sun that are a lot darker, a lot brighter. It depends on what filter you use, but there are areas when it's like really, really black, it's very hot, and it's a concentrated area of heat and extra charged particles. And what happens is sometimes when those sunspots will explode, it releases a whole bunch of energy and charged particles, and this is in the form of electromagnetic field and plasma. And so now when the sun explodes and lets out these charged particles, if say my head is the sun because I'm blonde and this is Earth, if what area is facing Earth, because it's on a tilt, so it's just why it's like on tilted on its axis. Let's say that I just part of me like explodes, and then it's coronal mass ejection. Woo! It interacts with the Earth's electromagnetic field, and when this interacts with the Earth's electromagnetic field, because the coronal mass ejection is charged particles, because it's part of the electromagnetic field of the sun and it's plasma, it interacts with the electromagnetic field of Earth, and they kind of dance a little bit, and this is actually what forms different auroras, which is really cool, or northern lights. And auroras are just because it's a combination of electromagnetic field on top of which you have the elements in our atmosphere that are interacting with it. So areas that are more concentrated with oxygen tend to be green, and areas that are more concentrated with nitrogen tend to be pink. So those are the different colors of auroras. Yeah, okay, so anyway, I forgot to say concluding notes. That's everything about coronal mass ejection. And I'm curious, where are you guys going to be for the solar eclipse, August 21st? Comment below, let me know where you're going to be, and maybe I will make a surprise visit in one of those locations. I'm still actually trying to decide where I'm going to be going for the solar eclipse. There's a lot of really good options right now, but trying to figure out which one. Okay, bye guys.